go. So, this is test week. We are going to be having a test on Friday. The objective of the classes during this week is test review. So we shall be reviewing them. Don't look so glum. It's just a piece of paper. Well, several pieces of paper stapled together. So the test is going to be Friday in the normal method. It's going to be pencil and paper as usual. So, review topics. Here's a question for the test for all of you. What have we covered since the last test? Arrays. I want arrays. Ha ha. Yes? You were going to say arrays? Yeah. Instantiate. So, what are you instantiating? Methods? Do you instantiate methods? So objects are a thing that we will need to instantiate, right? We'll need to do a couple of other things with objects as well. Basically, the test is arrays and objects, right? We've done some stuff with arrays, we've done a lot more stuff with objects. Basically, you've got like the two categories and then it breaks down further. So what are some of the things we talked about with respect to objects? Inheritance, yes. Inheritance. What else? Classes, yes. So class, object, distinction. Anything else? Constructors, sure. Constructors. Anything else? Well, we can start there, and as other things come up, we can deal with them. So, where shall we start? You'll have to speak up a little bit. The fan is very loud. Sure. We can start with arrays. So, what is an array? Anybody? Yes.
Did we describe that with this? Can teachers or straight say
A list of things. Not a bad definition. Elements. Yes. So an array is a list of elements. Now, I'll give that to you in this course, but once you guys get to data structures and algorithms, you will find out that lists and arrays are actually different things that are stored very differently in a computer science sense. But for the time being, that's an okay. You're not expected to know the distinction between arrays and lists at this time. That's coming.
I was going to ask you, lists
already got enough on our plate. You'll get there in a second. So, let's go from the fundamentals up. If we imagine a view of computer memory, as always, represented as a cylinder. An array is a region of memory that we block off and we say, this is a series of variables that are all adjacent to each other, that all have the same name. We access different elements of the array using numeric indexing. So, if I have a chunk of memory that's been set aside, that memory is subdivided into elements. Let's say integers, for instance. 8, 3, 9, 7, 2, 1, 0, 6. Right? We take some integers, we pop them in. Right? This whole thing is given a name, right? Perhaps ARR for array, right? The way that we access the individual elements of this array is using the following notation. Square braces, and then we provide a number such as 3. Right? So far so good? Good. There is one tricky part, though. Arrays use 0 indexing, not 1 indexing. So the element of the array at index 3 is the 4th element by counting, because 0 is included. This is element 0, 1, 2, 3, 4, 5, 6, and 7. So, array at 3 yields this element, not the one previous. There's a reason for this, but we don't have to get into it right now. This is testing. So far, so good? Any questions? Okay. So, as your colleague very kindly noted, I am recording this, aren't I? Yes, I am. Okay, good. As your colleague very kindly noted, although I typically use integers a lot, sort of in class as examples, you can have an array of any type. That includes classes and primitives, right? You guys know the difference? Have I used the term primitive before? So, although the term is not quite PC, the primitives are the collection of data types that are non-composite data types, right? So, integers are not a composite data type, it's just a number, right? Same thing with floats, doubles, booleans, right? All of these things are just a single value. The other thing is characters are just a single value. So these are primitives. We then also have composite data types. Composite data types include things like arrays and objects and strings. That's right. I was just about to put that as a question out to the class actually, so good job. So strings. How are strings defined? What is a string? Someone other than you. Let me see. You're pulling too much weight. What is a string? How is it defined? Collection of characters. So strings are not merely collections of characters, they are actually arrays of characters. Now, it depends slightly which object-oriented language you're using. The version of strings that you see in a language like C is a direct array of characters. In fact, most of the time in C, you don't even declare this string data type. You declare a character array. That is how you do it. In higher level languages like C++, C#, C++, Java, etc., the string data type comes packaged with some string methods as well. So string can be an object or an array depending on what language you're in, right? But even if you're in a language where strings are arrays, you will have access to things like the C standard string library, which provide all of the string functions that you will ever need. So far, so good? So, you can form arrays of anything, primitives and composite types, right? So, you can have an array of integers. You can have an array of arrays of integers. This is how you might represent two-dimensional data, such as, for example, a chessboard, right? You would have an array of arrays. Make sense? Question?
So you can have an array with a character and a string. Like you can mix the composites and primitives.
So this is the one distinction between arrays. This is one of the distinctions between arrays and things like lists. Arrays, while they may be formed from any type, they are monotyped. All of the elements of an array must be the same type. Yes. Make sense? Any questions? So, let's move to declarations. So, when we declare an array, how do we do it? What's the syntax? Well, first we need the type of thing that the array is going to contain, right? Let's imagine, for this example, we'll pick doubles, right? We use the base type, double. We then give square braces to indicate that this is an array. Double array, we then give it a name the same way we do any other variable. Double array x. Right? This is the declaration of the array. Now, all we've said here is that x refers to an array of doubles. we have not given it the size, and we have not actually instantiated it in memory just yet. We have created this part, but not that part. Does that make sense? To create this part, we must go on to instantiate the array. To instantiate the array, there are a couple of ways of doing it. One, if all the information you have is the size of the array, this is the declaration line that you use. X is equal to new double array of size 10. You would substitute 10 for whatever it is you want. This can also be an expression. This could be an input parameter from a function, which hopefully you all learned when you were doing assignments. Was it assignment 1? Assignment 1 was about arrays. Assignment 2 is about Windows forms. So, good. If all you know about if all that you know about the array, would it be helpful if I lowered this?
It doesn't want me this, it doesn't really matter.
Yeah.
So,
Is this even connected? I think this is
no,
stuck in
it's-
this position.
yeah.
Yeah. Okay. Sorry. You may wish to move more towards the middle of the class. So, there is a second way to declare the contents of an array. This is what you use if you know the contents that you wish to put into the array at the time of declaration. You say, and this must be done on the same line that you're declaring the array. You say x is equal to 4.3, 2.7, 5.5, etc. Something like that. So, in this case, we don't have to provide the size of the array to instantiate it. Does anybody care to guess why? Why don't we need to provide the size? Yes.
I just agree that there's three.
Yes. The size is already given in the number of the number of items we are instantiating with. So we don't need to declare the number of elements because we have given the number of elements. Make sense? So far so good? Any questions? Okay. So, the next question we might have, let's write an algorithm to work with arrays in some manner. We'll solve a simple problem. So let's say we have an array of yeah, sorry.
Yeah, just question.
Sure.
So when you do double array, you do like 10 elements. What are the values of those elements?
That's an excellent question. So the question is, if I do the second one, what are the values? Right? So it depends on what the base type is. Right? Each one of these primitive values has a default value. Right? So for ints, it'll be 0. For floats and doubles, it'll be 0.0, which is functionally the same. Booleans, it will be false. And character, it likely defaults to the null character, which is, again, has an integer value of 0. So if your array is of a primitive type, it will pull in one of these. what it will do is it will give you a default value of null, right? So that is to say this reference doesn't exist, right? So for example, if I wanted to create an array of objects, cat array my cats, for example, equals new cat array of size 30, because I have a problem. If you were, like with just that line of code, if you were to say, if you were to print, forgive the pseudocode, if you were to print my cats at 2, right? Just pick a random element out of it. That prints as null, right? If you try to access the properties of it, you'll get a null reference exception, which you can get in Unity really easy, right? I'm sure we've all had it. So, the question then becomes, how do we fix it? How do we replace these null references with something that's non-null? This is kind of pulling into objects just a little bit, if you'll forgive me. So basically what we need to do is we need to loop through the array, create a new object for every element of the array, and store the returned references to those objects in the array. So, first things first, let's write a loop that iterates through every element of the array. There are two ways to do this. For instantiation, you actually can't use a for each loop. You must use either a while loop or a classic for loop. So, for loops are a little bit easier. Let's use a for loop. For int I is equal to 0, I is less than length, what would it be? mycats.length, I think, in C#, is that correct? Something like that, right? I plus plus. See, that one is a particularly tricky one for someone who teaches several languages, because in every language it's just slightly different. So mycats.length, it might be capitalized. It's okay. If you, on your test, put it down capitalized or uncapitalized, I don't really care, so long as you're getting the concept across. So, mycats.length. mycats at I is equal to new cat, and then, that's a constructor. If you needed parameters, you'd throw them in. There you have it. Right? This is a loop that iterates over every element in the array sequentially, starting at 0 and running to the end. Right? So far, so good? So here's a question. How would you go about writing a loop that iterated the other way around? Right? So this one, here. So we want to start at the end and go to 0. Sorry.
No, that's all right. Got 30 cats of fast. Should I change this to 30? Get a big 3. No. Yes. Then I less than the cat. Yes. 30 and less than. Yes. No. Yes. No.
I can't cancel this.
So you start at 30. Oh.
gotta do one more thing. This is correct, you gotta do one more thing.
It's not this. Or it can't be one thing.
You gotta do two more things, you
Oh,
just did one. Back. Technically it goes the other way around.
Still less than. Well,
Okay, so let's think about it, right? Alright, thank you. Big hand, everybody. So let's take this as you wrote it. I'm just gonna, it would be, so do you want less than or equal to or greater than equal to here?
I want I to figure something.
So, greater than or equal to?
Yeah.
So let's take a look, do a tiny little program trace, and see how this behaves, right? In fact, we only have one variable I. So, we start off with I being equal to 30, right? So, recall zero indexing, right? I being 30 means that, like, let me put it this way. If we have an array of 5 elements, right? The indexes are 0, 1, 2, 3, 4, right? So, the maximum index is 1 less than the size of the array. So, in this case, I'm going to do it in red pen. You'll want 29, right? So you were right. I would say this is generally bad practice. What you want to actually pull in is this minus 1. Right? You want to make it dynamic on the size of the data, right? That way, if you change it up here, make the array a little bigger or smaller, maybe I get a handle on my life and I have fewer cats, you know, then you don't have to rewrite this code because just because you changed that up there, right? The fewer changes, the more you can kind of look ahead to these types of changes, the better your code will be for maintainability and your own sanity. So, number 1. Number 2. So let's imagine we started off at 29, right? So, here we go. 29, is that greater than or equal to my cats.length? Yes. So, we iterate, and so my cats at 29 is instantiated. Good. We then subtract 1 from I. So, well, actually, let's think about this for a moment. What is the actual value of my cats.length? So this is 30, right? So length is 30, right? So let's roll this back a little bit. If I is 29, is 29 greater than or equal to 30? So what actually happens is you skip the whole loop, right? So what should we replace this? Anybody else in the crowd is happy? I would be happy and pleased for anybody else to jump into. It's just like have a tendency when like a person is, conversing with me that I talk to the person who's talking to me, but if anybody wants to jump in. Yes?
Could you not change it to less than or equal to, because the option is less than that?
Well, okay, so let's imagine that this is changed to less than or equal, okay? So 29 less than or equal to 30. Yes, we iterate on that. And we subtract 28, 27, dot, 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 2, 1, 0, negative 1, negative 2, negative 3, right? Anything past here, depending on your language, will cause an array out of bounds exception and crash the program. Right, so this is the crash zone. Right? So how do you stop it before it hits negative values?
I is greater than or equal to 0.
I is greater than or equal to 0. Well, let's test it. Greater than or equal to 0. Yes. Dot, 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 dot. Greater than or equal to 0. Yes. Greater than or equal to 0. No. So we stop execution of the loop. We do not enter the crash zone. So that is the correct solution. So, in the previous version, we went, 0 was our initial starting point, and we built ourselves up to length minus 1. In this version, we start at length minus 1, and we go down to 0. So, in effect, we have still traced through every element of the array, but we have done so backwards. Yes?
If we were going up to length minus 1, we'd be writing like length minus 1. Like I is greater than or equal to length minus 1.
So, if you were to use I is less than or equal to length minus 1, yes. But if you just say I is less than length, that is correct, right? So at the boundary, right? Let's say length is so going up. 28 is less than or equal to 30 versus. Okay, let's make this into a chart. Less than or equal to 30, less than 30, right? So 27 is both less than and less than or equal to 30. 28, yes. 29, yes. 30 is less than or equal to 30, but 30 is not less than 30. Sorry. Oh, there we go. Right? Now, of those two, this is the one that maps to indexes. Right? This is the one where all of the check marks are valid indices. So that's the one people generally use, because to get this one to do that, you have to subtract 1. Make sense? Yeah. So yes, good questions. Very good questions. Is this making sense to people? Yeah. Like, I know it seems complicated, but really is just all math under the hood. It's just math. Everything is just math. Addition, subtraction, multiplication, and division. Yes?
So, how does it know what elements the cats are?
How does it know?
String, like, so if we put string array in front of cat, I have an array start.
Oh, the cat is an object. Or cat is a class, so we are creating new cat objects. Right? But this same procedure would apply if you wanted to initialize it in any other way, right? If you wanted, a relatively simple one is if you wanted to initialize every element of the array so that the array of integers says like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? This would be the thing to do, right? Let's imagine you have int array q equals new int array of size 1,000 million. Yes, 1,000 million. There we go. That might be too large a number, but that's okay. For int I is equal to 0, I is less than q dot length. Q plus I plus plus q at I is equal to I. What does that program do? What is the result?
Just like goes to the array that has each next 1, 2, 3, 4, 5, 6, 7.
Yes. So this produces an array, 0, 1, or sorry, actually it starts at 1. Does it start at 1? No, it starts at 0. 0, 1, 2, 3, 4, dot, 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 all the way to 1,000 million. That's what test does. And you can see that that is much more efficient than writing it out like this. One might even say that might be impossible for a human. Basically, to do that, you would probably write a program to generate the numbers and then feed those numbers in as a literal. But if you're going to do that, you might as well just write the program here, right? So, arrays. Any questions? Anything you'd like to see done with array? Yeah.
Will there be like the assignment we have with arrays? Will there be questions on the test like those questions on the assignment?
Quite possibly. I can neither confirm nor deny. You may very well think that, but I couldn't possibly comment.
Can you go through some of those questions?
Well, I certainly can't give you like the questions on the test.
Oh, no, not the test.
But let me see if I can use my brain to spontaneously generate an array question such as you might find on the test. Well, let's do it with primitives rather than objects, because that way we can do like some math. Let's say we want to calculate root mean squared. So, if you guys want a photo of this, please take it now. All good? So root mean squared is an algorithm that is occasionally used in electrical signal processing to measure various things. It's not important. The important thing is that what you do is you take a signal, right? Which a signal would be a series of values, right? So the elements of an array. You square all of them, you sum them all, and then you take the square root of the sum of all of them. So let's implement that, all right? So let's say that in terms of a mathematical formula, our root mean squared of x is equal to the square root of the sum of x squared. Right? Good. So, let's first, so do you want this to be like a function, or do you want to have the array declared?
Function.
Okay. This is a function, so that makes sense. Sure. Public, sorry, I had to, the gears had to click into C# mode. Public, the result of this will be a double. Public double RMS, taking a double array X. Right? So far so good. So the other reason not to hard code the limits on your arrays, as hopefully you folks found out during the assignment, is that hard coding the limits on the array is not possible if you don't know the size of the array anyways. To write a good function, you shouldn't know the size of the array the function operates on. That way it applies to all arrays, right? So, that's why you should get out of the habit of hard coding. You want to try? It's okay to say no.
It's not optional. You got it?
Yeah. Anybody else want to grab the marker? Okay. So we are keeping a sum. Similar to the sum question on the assignment, we will need a variable to keep track of the sum. Double sum. Set its initial value to 0, because the initial value of any sum of anything should be 0, right? There are these interesting numbers that have unique mathematical properties, right? 0 added to anything is the thing you added. 1 multiplied by anything is the thing you multiplied against, right? These are the types of values you want for initial values most of the time. So, we now must enter the loop. The loop will occur very similarly to how the loops have occurred so far. For int I is equal to 0, I is less than x dot length, I plus plus. By the way, if I wanted to skip, if I wanted to start at a particular value and only do every other element of the array, I could do something different here, like I plus equals 2. But you don't have to use plus plus or minus minus there, right? You can actually use whatever you want. Okay? But in our case, I plus plus is correct. So, we want to compute the sum of all the squares of the square of every element. Right? Now there are two different ways of doing this. I think the easier one is to simply say sum plus equals x at I times x at I. Anything multiplied by itself is defined as the square. You don't have to load any fancy math libraries. And the other way of doing it is to do exactly that and load a fancy math library. Sum plus equals math.pow, which stands for power. It's not pow, it's power. And that will be x at I raised to the second power. Math.pow is a very, very flexible library. It will raise something to any exponent, right? That exponent can be, well, it doesn't do negatives, right? Why doesn't it do negatives? Math question. Hmm? Yeah. Why wouldn't it? Oh wait, no. What am I thinking about? Yeah, no, square root is the reciprocal, right? So x squared is one thing, right? X to the 1/2 is the square root of x, right? So what is x? X to the -1 is the reciprocal of x. X to the -1/2 is 1 over. What am I thinking of? No, I'm thinking of the square root of the negative. Maybe. Yeah, I'm thinking about the imaginary number. Anyway, I digress. The math library is very powerful. This can also be a decimal number. This can be a double, and that still works. Pardon me, but if you use it, like, if you try to take something that would result in an imaginary number, it will flunk out on a domain error. So, because you can't take the square root of a negative. That's the math thing. You can't take the square root of a negative. You can, but you have to introduce the imaginary number, which, yeah, you have to take I out of it. It gets complicated. It's easier to just have an error, right? Yeah. Have you seen this joke? It's be rational. Get real. Right? Because I is an imaginary number, not a real number, and pi is a irrational number, not a rational number. By the way, what does it mean to be an irrational number? Yes?
Irrational is non-repeating, never-ending, not put in a fraction.
Yes. There is no ratio of two numbers which fully describe the number. Pi is one of those things. So, good. All right, we're getting a little sidetracked. So, that'll work step. We have computed the sum, we now need to compute the square root. Return math f, or math f, whatever it is, square root sum. And that is the whole enchilada. I would even consider this one to be an easy question because there's no if statement required in here. Right? I could say something just to kind of jazz the question up a little bit. I could say something like, give me the root mean squared for every element that's greater than 2. Right? And then you put, if x I is greater than 2, then add it to the sum, otherwise don't. Right? Actually, I think my root mean squared is incorrect. I think you have to divide by n, like here, but it doesn't matter. It doesn't matter because this isn't a digital signals processing class.
Good.
Yes. So, there, we did an example. Any other questions about arrays? I have a question for you. Why did the programmer quit his job? Because he didn't get a raise. So, if you want a photo of that, please take it now. I think we're going to move forward to objects. All good? All right. I don't see any phones out, so I'm going to erase it. There's like this weird dip in the floor right here. It's like the slopes down. It's weird. I'm in a depression right here. So, objects and classes. All right. We will start with the class-object distinction, as all other information in this topic flows from that point. All right. So, classes are to objects as primitive data types are to the variables that you declare from them. All right? So if I have a class, my class, actually I will capitalize this. It's conventional that class names be capitalized. My class Q, integer x. This is the object, this is the class, this is the object, this is the type, this is the variable. Make sense? So an object is a thing that you instantiate from a class. A class is a blueprint for the creation of objects, right? The object is the thing that actually physically exists in the program, insofar as anything physically exists in a program. It's the thing that you get your hands in and you manipulate. It's got actual real data in it. You call methods on it. It exists. It's been instantiated. A class is a concept, right? A class is a description. A class is a category. It doesn't exist until there is an object that instantiates it, right? It's a little bit cerebral, but it's a bit like the distinction between the concept of a cat and an actual cat, right? Yes?
Is it like apples? Fruits not existing before they're eating apple?
Well, see, unfortunately, things have to get a little bit metaphysical at this point. So, because the question is, right, does the category precede the actuality, or does the actuality precede the category, right? Does the category of apple exist because there are particular apples, or are there particular apples because there is a category for apples? Well, that's getting into inheritance, so let's leave that on the table for just a moment.
Class is apple, it's fast, it's
Yeah, so,
an object, specific.
say that a little louder?
Object would be like a specific red apples.
Yes.
Class or others.
Like, if you wanted a name for the specific red delicious apple that I am currently eating because I'm into garbage apples, that is the object, whereas the general class of all red delicious apples, that is the category. Now, you can make one of two arguments, right? A naturalist would say something like, the category only exists because we have abstracted it from the physical strata, which is the thing that definitely exists, right? A metaphysicist would say, the category of apple preceded the existence of apples, right? Like, it's kind of like a little bit related to the idea of the Platonic form, right? So, like, the only reason that human beings see an apple and recognize an apple as being a distinct entity is because we came pre-programmed, in a sense, with the concept of the form of an apple which this object matches, right? So that's the metaphysical approach, right? The materialist approach is that the material precedes the category. The metaphysical approach is that the category precedes the material. And in programming, it's a metaphysical world. The category precedes the object, because the category must be declared in order to know the properties of the object. At least in, okay. In C sharp, all right? In C sharp, it's a metaphysical language because categories must precede the object, right? C sharp and Java and C++ and all good languages, all right? The category precedes the object. You must have a solid definition of the class, or else you cannot create an object. But in these loosey-goosey materialist languages, you can declare empty objects, and then you add properties to them as you go along. So you don't actually need a class definition in order to create objects in languages like Python, PHP, and JavaScript, which are generally less nice languages to work with. You know, it's like, anyway, I don't want to belabor that analogy too much, but yeah. So here in this class in C sharp, you must define the class first, then you can create an object from the class, and then you can work with it. But you're not permitted to add properties or methods that you didn't give it in the class, right? Objects are strictly defined by their classes in C sharp, and Java, and C++, and pretty much any static compiled language, right? Yes?
Add a class to an object, that would be part of all the class.
Can you add a class to an object? You can so the problem we run into is, what do you mean by out? Right? There are two different ways we discussed of doing this in class,
Yeah.
right?
So we had like enemies, and they had like multiple pages, I assume those are two classes.
Mm-hmm.
They had two different, one was for spawning them, one was for
So so when you say add a class to another class, right? There are two ways of doing so, and none of them resemble arithmetic, right? So the first way is to add some material to one class by saying it is a sub-variety of another, right? So this is a that. It's an existential operation, right? This is a type of that. This is that, right? So, for example, apples are a type of fruit, right? So apple is a subclass of fruit. Fruit is a superclass of apple. So we would say fruit is so we would say that apple inherits from fruit. Right? So far, so good? Apples have.
So move on, that's.
Alright. So what were we talking about? Classes. Ah, yes. We were talking about apples and classes and metaphysics. So, so apples are a type of fruit, right? You could shorten this to say apples are fruit, right? Apples have seeds, right? So the thing we think of as an apple is not it's not a simple entity, right? Everything that we think of is composed of parts. The further scientists look down into the substrata of matter, the more little bits and bobs whirling around that we find, right? Apples are composed of parts. You have the skin, you have the flesh, you have the seeds, you have the stems, right? So, at a certain point, you take a definition and to actually, provide a little bit of, something to operate on to the class, you say, an apple has, skin, seed, perhaps an array of seeds, flesh, and stem. Optional. The presence or non-presence of the stem does not make or break the existence of it as an apple, right? Your apple in the supermarket may or may not have a stem. I would say your minimal set of things the apple needs to have to be considered an apple is probably these two. You need the seeds and you need the flesh. A peeled apple is still an apple, right? But once you've cut out the seeds, you are not talking about an apple anymore, because you've had to dissect the fruit in order to remove the flesh. You are talking about just strictly apple flesh as distinct from the seed, right? So that is composition, right? The apple is composed of different things, right? It may share these characteristics with other types of fruit, right? A blueberry has seeds, has flesh, has a skin, right? But so fruit, the category of fruit, includes in its definition the set of attributes common to all fruit, right? That's what fruit is as a category. In fact, you could say that the category of apple contains all attributes common to all varieties of apple, right? If you take Red Delicious, Macintosh, Gala, all of the different types of apples, there are some concepts shared by all of those different specific apples. That is what you collect up into the definition of an apple, right? With me? So far, so good? Okay. In programming, when you write a class, you are trying to write things according to this scheme of categorization, which I have described, which is the actual way that human beings think, right? Human beings think in categories more so than in like specific objects, right? Like, it's necessary to do so, otherwise you wouldn't be able to process things fast enough to interact with the world. A good example is these stupid things, right? When you sit down at a keyboard, right? Well, even if you look in this room and you look at all of the individual keyboards in this room, you do not think of each one as being its own distinct object or entity. You think of it as a group of keyboards, right? And that is correct, because if you were hyper-focused on all of the individual detail of each keyboard that you encounter in your life, to the point where they exist as separate categories in your imagination, you would not be able to type anything, because you'd be too busy spending your time examining keyboards, right? Yes? What about that, sorry?
Music playing keyboard.
A music playing keyboard. Well, yes. So keyboard itself has subclasses. When I said keyboard, I of course meant the computer keyboards, but musical keyboards or instruments with keyboards, you might say, you know, the electric keyboard, that is a type of keyboard, right? Pianos also have a keyboard. Accordions are also an instrument with a keyboard, right? Organs, instrument with a keyboard, right? So you're kind of like, it depends on like how old you are, I think. Like, if you look at younger and younger children, they think in broader and broader categories, right? Like, to my 3-year-old, an apple is an apple, right? He doesn't really understand that there are different varieties of apple, you know? But, you know, we digress. So, when you are writing a class for a computer, you are trying to capture a general set of properties that will apply to a group of objects, right? So, an example I used in class, which I'd like to use again, involves geometry, right? It's a little bit easier if we talk about something mathematical. If somebody wants to suggest a different subject other than points and lines and that sort of thing, I'm happy to give it a shot, but I'd like it to be something a little mathematical. Geometry it is. So if we define a point in space, say we define a point in two-dimensional Euclidean geometry. This marker is beginning to wear a little thin. We can define the point by two values, an x and a y value, right? So, we are talking about a class because point is a concept, right? Therefore a class. We know we need x and y values to describe the class. So, class point has, let's say, float x, float y, right? We have our x and y coordinates. We might have a method in here which, distance to origin, public, float, distance to origin, which of course, if this is the origin, 0, 0, the distance to the origin is of course just Pythagorean theorem as applied to the two coordinates, right? So, return math dot square root x times x plus y times y. Fairly simple. So now we have a class that has attributes and a method. Does this make sense? Any questions? So far so good? So the question that we must ask ourselves is, what is the advantage of doing so? Right? Defining a point class allows us to work with objects of that class as variables in, a reasonably cogent way in other parts of the program. So, if, for example, I wanted to declare an object of class point, I would say point A is equal to new point. Point B is equal to new point. There we go. Let's review public versus private. All right? So, if these are public, this operation succeeds. A dot x is equal to 7, B dot y is equal to A dot x. These two operations will succeed because making them public gives us full access to the variables from outside the class. This is a context outside of the class. In Unity, this might be your start or update methods. In a C# console app, this would be like the main execution. Inside of a C# Windows Form app, this might be inside of a like a button click event or something like that, right? It's a different context from the class's declaration. Okay? Good? So far so good? Any questions? Okay? if I change these to private, this thing creates an error and this thing creates an error. You are not permitted to read or write from values which are private, not from outside the class. You can do so from inside the class. You'll notice that x and y are being read inside of this method, no error results. But from outside of the class, making those private causes these two statements to be errors. Make sense? Any questions? Do you have your hand up? Oh, okay. It's difficult sometimes with like the hands and the monitors. So if you have to raise your hand, please get it up above the level of the monitor so I can see you. So that's the idea between private and public. Functionally, that's the difference. In terms of why would you need that distinction, right? So it's kind of like, why would you want privacy at all, right? You know, human beings, we like a little privacy, you know. Some people like more privacy than others. But basically, if you have set this up so that x and y cannot be modified in this manner, you set it up so that you can control how they're modified. So let's add a new method. Public void set x with double new x. Let's say, just for the sake of interest, this isn't like applicable to this scenario, but you can imagine. Let's say, just for the sake of interest, x is not permitted to be less than 0, right? Perhaps we are taking the square root of it at some point in the calculation. X can't be less than 0, or it will make the program fail, or put you in some kind of error state. We don't want it to happen ever. If we make this public, and people are just grabbing that variable and doing whatever they want with it, they could very easily decide to put it into a value that would cause an error, right? They would put a negative value into it, not realizing that there's this problem where if you put a negative value in, it breaks the calculation, right? Therefore, they try it, it fails, you get a bug report, your boss is on your behind to get it fixed, right? If the value of x must be set through a method rather than direct access of a variable, we can control the circumstances under which it gets set. We can make decisions. We can control our data policy. So, for example, if x is less than 0, x is equal to 0, else x is equal to new x. Right? So in this case, x is not ever permitted to be less than 0. If somebody sends a value for x which would be less than 0, right? It stops it, writes 0 instead, and then stops. But if that's not the case and the value is valid, then it writes it in. So, how that changes the code here, rather than accessing x directly, we say a dot set x to 7. This no longer causes an error, right? So this is the purpose of private and public. You are setting the code up so that a complete moron, and by that I mean probably yourself, can understand the code later, right? So the problem is, by the way, I include myself when I say that. The problem with programming, and I'm sure, I actually don't think you folks have worked on a large enough programming project yet to have experienced this. You kind of have to do a project and then come back to it in like 3 or 4 weeks, right? But there's this problem where you write code 3 weeks ago, you then, you go and you play video games for 3 weeks. All of your brain, from all the video games, your brains just kind of ooze out of your ears into a collection cup, and you collect your brain and you drill a little hole in the top of your head, put a funnel in, and then pour your brain back in, put plugs in your ears to stop, coming out again, right? Because that's how video games you were those 3 weeks. You come back to your code, and you have completely forgotten everything you were doing, right? First of all, this is the reason you want to leave comments, right? They're not just for other people, they're for future you, right? Second of all, you are likely to forget all of these little conditions, right? If it's true that x should never be negative, if you just say, oh, I'll remember that x should never be negative, you won't. You will forget that, you will break your program, and then you will wonder why, and then you will spend 2 or 3 days debugging it to try to find out why, and then eventually you'll be like, oh, x should never be negative. And you will waste those days. Those will be days you will never get back. Right? You will be 3 days closer to the grave because of the fact that you didn't properly protect yourself from yourself. Right? Not to mention, your employer will not be pleased that you're spending this long doing these sorts of, stuff that's basic. So, does that make sense? So that's why you want to use private and public. Good. Minimal example of inheritance now. So, the geometry example is a little bit, like it falls apart a little bit because things aren't really, well, okay, here's one for you. So we have a point, right? Let's say we have another class in scope. Somewhat similar to Unity, class color, all right? Let's imagine that that's defined elsewhere. We don't have to define it. Let's say that we're writing points for a program that graphs something, right? We want to do points on a graph. A feature that you may wish for points on a graph is to be able to draw those points with different colors, right? So, we want to come up with a class which is a point, but it has this new color property. But we don't want to modify the original point because maybe this is also used by a geometry engine where that's not a useful distinction, right? Maybe this same class is being used to do like vertexes in a wireframe or something, right? So in such a case, we would write a new class data point, and we would inherit from the original definition of point. A data point is a type of point, right? Data point inherits from the definition of point. So what does it functionally mean in code that we are inheriting? All of these definitions, all of them, are copied and pasted here, more or less. You still have to use, like, inheritance will respect public and private. So if you're inheriting from a class, you still have to access things through its methods, if they're private, right? But float x, float y, distance to origin, and set x, those are all definitions that will carry forward to the derived class. By the way, this is the derived class, and this is the base class. All right? Point is the base class, data point is the derived class. So, what makes a data point different from a regular point? The inclusion of a color, right? Color C is equal to, oh, who knows, initialize it to color.red, right? You can also add new methods that apply to the new data. So, for example, change color. Let's make it private. New method, public, void, color change, color n for new, C is equal to n, and method. There you go. Right? So, the data point class picks up all of this stuff. So it still has an x, it still has a y, it still has distance to. We now add these additional definitions, and we end up with a thing that is further specified. We're talking about a more specific type of thing now. That's always the way that inheritance works. The base class is always less specific, and the derived class is always more specific, right? Think about fruit. Apple inherits from fruit. Fruit is a more general sort of thing. Apple is a more specific sort of thing, right? Does that make sense? Fruit might inherit from another class, plant part, right? Which would include things like, roots, branches, leaves, rhizomes, all of the things that compose a plant, right?
We have like pulp.
Yes, so, okay, let's do it. So let's imagine we have apple, right? That will inherit from fruit. Fruit inherits from plant part. So what is a general category that includes plant parts and other sorts of things? Nature? Nature is, so it doesn't make a good category for our purposes if like, can you think of a nature? We can think of a plant part, right? And I know this is like a little bit different from how human beings work, right? But like a lot of the time when people think about nature, what they're actually doing is anthropomorphizing natural processes, right? So like, we think about nature, we think about some sort, like, if we see like a mountain vista and we say, ooh, what a pretty feature, it's like a description of the sense of awe and beauty people feel from encountering the natural in grand scale, right? But like if we think about the nature of something, right, that's a different way of putting it, right? Like what is the nature of nature? That's often like we are mapping like human concepts onto natural features. But I'll back away. So plant parts, things like roots, leaves, stems, fruits. What is a general category that encompasses all of those things plus a few more things? Yeah.
Sugar-based fruits.
Sugar-based fruits?
Sugar.
So sugar-based fruits, like that would be a subcategory of fruit, right? Yeah, we're past fruit. We're now to plant parts. What's a more general thing than the plant part? Yes?
Vegetation.
Vegetation. A plant itself is a plant part a type of plant? Yeah. So a plant part is a type of blank. In theory, for some plants, right? Like there are lots of different types of plants where like you cut a leaf off and you can grow a new plant from the leaf. But that's not a characteristic shared by all plant parts. Right? So I would say photosynthesizer is a description, like that's a property of plants. Right? Yes.
You go to super general say
So living, again,
plant.
is a leaf on its own a living thing. It's only a living thing if it's connected to a living organism, right? We've kind of picked a hard one, actually, right? So I would say the next category up is probably organ, right? So if you think about organs as being, like we typically think about organs in like the, animal sense, but a biologist would tell you that plants certainly have organs as well. If you look at like what the real definition of an organ is it's a collection of tissues that are all organized towards some purpose, right? That is a definition which fits all plant parts plus a few things beside, right? Animal organs, fungal organs, right? You were basically at this point describing the structure of multicellular living things, right? Does that make sense? Because an apple is an organ, right? A leaf is an organ of a plant, right? A plant is not an organ of a plant, right? So here's another fun one. How do you get more general than organ? What is an organ? Tissue, so tissues compose organs. An organ is composed of tissues. A thing that's functional that does work. We might call that, well, I'd call that a system. Right? A system, right? Now we are talking about very general concepts. But if you remember the definition I gave for an organ, it's a collection of tissues, not necessarily animal, animal, plant, fungal, doesn't matter. It's a collection of tissues organized to serve some purpose. When you organize things to serve a purpose, that's the term we use for that generally is system. But you can go other places with that as well. You could call it an organization, right? But let's go with system, right? So what is a system? A system is a thing that does something, right?
Systems have parts.
Systems have parts and goals, but what's more general than a system? You actually already said it.
Organs.
Nope, that's going the wrong way. A system is a thing.
Oh my god. It's a noun.
Right. So at a certain level of abstraction, you've become so abstract that what is even the point of this anyway, right? But it's true. Systems are a type of thing, right? Apples are all of these things, right? An apple is a fruit, an apple is a plant part, an apple is an organ, an apple is a system. Although it's weird to think of an apple as a system, an apple is a system. An apple is a system for the delivery of seeds to the earth, right? Apples are a thing, and nobody would argue that an apple is a thing. Right? So, and now for the part where I bring it back to code. Inside of object-oriented systems, you will have a base class that everything inherits from called object, typically. There will be one object class that everything inherits from by default. It's normally not stated explicitly, but when we wrote class point, inherent in that definition was the fact that it inherits object. Object provides a number of basic definitions which you may or may not want to change for your particular object. One, what does it mean to print this thing as a string? Right? That is defined in the object base class. It's probably not very useful for your, the base definition is probably not useful for your specific thing. I'm not sure about C#, but I know in Java, the default definition of printing an object gives you the memory address at which that object is located in memory, which doesn't really tell you about the contents of the object, but it is information about the object, right? And it can be useful information as well. But another basic definition that's provided by the object class is what does it mean for two objects to be the same, right? We have equality, like the double equal sign, defined for everything by default because object contains a definition for it. Does that make sense? Class is dismissed. Although that was somewhat rude of me. I didn't pause for questions before I dismissed class. Are there any questions? Yes. That is because I am an arbitrary tyrant, and the sooner you learn that about me, the easier we're going to be able to get on with each other. I like to think of myself as a benevolent tyrant. It's a parenthood thing. So, are there any questions about anything we talked about today? Yes, we're going to be continuing on our discussion. We'll talk about constructors. We'll do some more object examples. But yeah, review tomorrow as well. Okay. If you have anything you would like to have covered, please bring it for class tomorrow. I will be answering questions. You have a question?
Is there a chance you can close this video tonight?
I can get it. I can do it tomorrow. I'll tell you what I'll do. Send me an email to remind me. I'll do it tomorrow morning, and like I normally set them to be published at midnight, but I'll publish it like at noon or something as soon as it's done its processing.
So do I email you today or?
Email me today, so that you don't forget, so that I don't forget, because I forget. Good. Any other questions? You had a question? No, it is on paper. That's not true. That's all not true. Yep. Yep. It's just going to be on paper. Trust me, you don't want to write that test. All right? The test that's described there, you don't want to write it because you want to know what those labs were before I changed things to paper tests. It was, you got 2 hours, now do this lab.
You only get 2 hours just in class.
2 hours in class, do this lab. So, do you hate the paper tests now? All right, I'm out of here. Take her easy.